Hello students, welcome to Target IES. In this video we are going to continue with module number 13. Okay, in the module number 12 we have seen how to calculate the strain energy stored in the member due to the applied loads, right? So, but the chapter heading was to find the deflection in statistically determinate trusses. But we have calculated strain energy. What we have to calculate? We have to calculate the deflection. So there should be some relation, right? If you are studying strain energy, there should be some relation. That's why you are studying strain energy. The relation between this deflection and the strain energy was given by Castigliono's. Okay. So there are two important theorems of Castigliono's, theorem 1 and theorem 2, both super important. See, for sure, ESC, GATE, PSCs and PSUs in this particular year are going to ask question related to Castigliono's. Why I am so confident? Because this question comes almost every year. If you are studying structural analysis, by default there will be one question in almost all examinations related to Castigliono's theorem. It can be a problem or it can be directly a theory question. Okay, if you are taking PSC and PSU exam, direct theory, just from theory, whereas ESC and GATE, they might ask problems from this theorem. Okay, first let us read this theorem and then I will give you a small note or hack. Using this hack you will never forget these theorems. Okay, so this is similar to that of the Newton's law which you have studied in 8th or 9th class. Okay, in almost all exams Newton's law used to come. Similarly, almost all exams related to civil engineering, there will be a question of Castigliono's related to structural analysis. Okay, so what is the theorem 1? The first theorem, you remember it as first theorem. So what does the first theorem say? For elastic structure, the partial derivative of total strain energy with respect to displacement gives force. Okay, so if we partially differentiate our strain energy with respect to the displacement, what we will be getting? We will be getting the force applied on that member. Okay, the force which is causing that strain. Okay, now let us see the theorem 2. It is just opposite. You can just switch this. Okay, you can switch S with F, you will be getting your answer. Okay, so for elastic structure, the partial derivative of total strain energy with respect to force or moment give the displacement, that is deflection or rotation. Okay, so in the previous case, F was dou by dou S, send S here and F here. What you will be getting? Your S displacement was nothing but dou by dou F. Okay, done. See, when I am talking about displacement now, there can be two things. It can be linear deflection or there can be angular deflection, which is nothing but the rotation, right? Right, agree. There are two types of displacement. One is linear and other is angular. Angular displacement is nothing but rotation, whereas linear displacement is nothing but deflection. Okay, so to get deflection, what we have to do? We have to partial derivative your strain energy with respect to force. Okay, the force which you are applying. To get this angular rotation, what you have to do? You have to partially differentiate your strain energy with respect to moment. Okay, strain energy with respect to moment, you will get rotation. Strain energy with respect to force, you will get displacement. Never forget this. These three super important, and these three formulas you should never forget. Now I will give you hack. Okay, so in the first theorem, basically the people confuse between whether in first theorem you get displacement or force. Okay, see, first theorem, F, it starts with F. So what you find? We find F only in the first theorem. We find the force. Okay, if you want to find the force, you will never make mistake. Dou U by dou S, you will never make mistake. Okay, in the second theorem, right? This is the second theorem. It starts with S, so you are finding the displacement S, dou U by dou F. That's it. You remember like this, you will never forget, or else you will definitely have some confusion. Even when I was appearing for ESC or some examination, I made the same mistake. He asked me the deflection in the member is obtained by which theorem? Castigliono's 1, Castigliono's 2, and there were so many. I have selected Castigliono's 1, whereas the answer is Castigliono's 2. Displacement yani? Yes, right? Yes, you get from second theorem. Yes for yes. Okay, force you get from first theorem. F for F. Always remember this small note. Make a note. Please make a note. Never forget it. Or else तुम बोलोगे कि सर ये तो याद हो गया, हम कभी नहीं भूलेंगे. But obviously after 10 days or 15 days you are going to forget. So please make a note, clear note, and write this hack. F for F, S for S. Okay, so that you should never forget. Now there is one important note. which has been asked in numerous number of examinations. What is that note? Just give me a second, let me erase it. And these two are super important. Okay, if you want to find deflection, this chapter revolves around deflection only, right? What you have to do? Dou u by dou f. Okay, and if you want to get rotation, what you have to do? Dou u by dou m. That's it. Now coming to the note, theorem 1 is applicable to both linear and non-linear elastic structure. Even if the member is linear or even if the member is non-linear, the theorem 1 can be applied. There is no issues. But theorem 2 can be applied to only linear elastic structures only. This is super important. Always remember, theorem 1 you can apply to any elastic member, whereas theorem 2 you can apply for only linear elastic member. You can't apply for non-linear members. Fine. Done. Now let us calculate the deflections due to the applied load. Okay. So basically there are 4 methods by which we can calculate how much our truss has been deflected. Okay. The deflection of a truss joint can be found out by unit load method, Castigliono's method, joint displacement method, and Willett mode diagram. See, Willett mode diagram, you have to remember it for objective purpose. Give it 3 star. Always remember, it is a graphical method used to find deflection of a joint, truss joint. Okay. So this question was directly asked in ESC. He asked, what is the graphical method used to find deflection of a truss? The answer is Willett mode diagram. 99% of the students don't know this answer, because we won't be using it in structural analysis, because this is a complicated process. We won't be using it. Okay, so we have to remember only for objective purpose that Willett mode diagram is a graphical method to find out deflections. Okay, so we will be using only unit load method. It is nothing but it is the extension of Castigliono's method. So let us see this unit load method. First of all, we have just seen from the Castigliono's theorem 2 to get deflection. What was the deflection? Dou u by dou f, right? Agreed. What is u? Strain energy stored due to gradual loading. So it was summation of the axial forces square L by 2AE. Okay, you can just go up couple of pages and see your hard copy. The strain energy due to gradually applied load, summation of W square L by 2AE, where W was the axial force, right? Here the axial force in individual member is P. So summation of P square L by 2AE. Okay. So now let us partially differentiate our strain energy with respect to force to get our deflection. Okay. Simple enough. Kar do partial differentiation. What you will be getting? P square L 2AE ka partial differentiation with respect to force. What you will be getting? 2P dou P by dou F L by AE. AE. Okay. You can see here, yeah, this step you will be getting 2P dou P by dou F into L by 2AE. Okay, this dou P by dou F, this 2 cancel. Okay, dou P by dou F I am writing as some constant K. Okay, so what is the deflection? Summation of PKL by AE. Okay, what is the K? K is force in all members due to virtual unit load. So your P was force in all the members and K is force in all the members due to virtual unit load. Let me tell you here only very clearly, make a note. So where to apply this unit load K? Okay, where to apply this unit load to get K? So let me give you a rough example. Okay, this is a very rough example. Say yeah. So here I have applied some load W. Okay. So because of this W, there will be axial stresses developed. So we'll be getting some P1, P2, P3, this one is 0, this one is 0 member, this one is 0 member, 0 member. Okay. P4, P5 like this, right? We'll be getting these P values. That is very clear. For example, if I want deflection at C or deflection at D, okay, due to this unit load. If you want vertical deflection at D due to this load W, what you have to do is you have to remove this W now and apply unit load at the point wherever you want deflection. Okay, we are not applying this unit load in the place of W. Remember, many people make a mistake here. Okay, we are not applying our unit load in the place of W. You first have to calculate the P, the axial forces developed in the members because of this load W. That is your first step. After that, remove this W. No need of this W. Just give me a second. No need of this W. Remove the W and place this unit load wherever you want deflection. If you want vertical deflection, place vertical unit load. If you want horizontal deflection, for example, if you want horizontal deflection at joint C, this unit load should be applied in this direction. Okay, because of this unit load, there will be again axial forces developed, right? Those axial forces in all the members you have to calculate. That axial forces due to this unit load is represented by K. Simple. Confused ho gaye pakka, but as we are solving problems, you will be perfect in it. Okay, let me repeat this again because it is so important and so many people make mistake because they don't understand the concept well. For example, if I have a truss like this and at this point let this be A, this be B and this be C. I am using only 3 points. So if I want deflection at C point, okay, vertical deflection at C, what I have to do? First I have to calculate what are the axial forces. Say this is W. I have to calculate the axial forces in the member because of this W. P1, P2, P3. So you will be getting your P values. Now remove this W. Now remove this W. This is the second step. We have to remove the W and place this unit load wherever you want. That's why it is called as unit load method. For example, you want vertical deflection at C, right? What you will do? You will place vertical load at C only. Okay. So you will place vertical unit load at C. Now because of this you will be getting the axial forces again, right? These axial forces will be K1, K2, so on. Okay, so these K1, K2 you have to use in this formula. So sigma PKL by AE, right? So you will be getting P1 K1L by AE plus P2 K2L L1 L2 by AE plus P2 P3 K3 L2 L3 by AE, so on. Okay, that is your sigma PKL by AE. If you summate all the forces, you will be getting your deflection. That's it. Simple, eh? It might be complicated. Even if you don't understand after explaining twice, don't worry. Don't worry. When you are solving problem, you will be 100% sure. Okay. Now see this important note. Where am I? Yeah. To find K in all members, we should apply unit load where we want to find deflection. Very important note. Very important note. Many people make mistake. They remove W and apply unit load at the same point. Never do that. We have to apply unit load wherever we want to find deflection. Okay, at the joint wherever we want deflection. If you want vertical deflection, apply vertical unit load. If you want horizontal deflection, apply horizontal unit load. Let us see an example. You will be perfect. Now let us calculate the vertical deflection at joint A. Where is joint A? Here I have joint A. So what is the first step? First step, we have to apply the load whatever is given and find forces P1 and P2 in the member, right? There are only two members. So we have to find two forces P1 and P2 first of all. Now what you have to do? You have to remove the load and place unit load wherever point at whatever joint you want the deflection. Here in the question we want deflection at the same point where we have the load. So that is the only reason why I am placing the unit load here. Okay. Remove the 10 kilonewton load and place unit load there. Okay. Now calculate what are the axial forces because of this unit load. That will be your K1 and K2 values. That's it. Once you got these two values P and K, what you have to do? You have to summate sigma PKL by AE and you will be getting your answer. Simple enough. So let us calculate this problem. Let us find what are the forces. Let's say PA. Let this be PAC and let this be PAB. Okay. So what is PAC? How to get PAC? You can use sigma y is equals to 0 at this joint A. So let me take the sign like this. Sign convention is very important. Make a note here. If nothing is given in these problems, always take tension as positive and compression as negative. If you are taking compressive force, never forget to mention minus. Okay. If you are taking a tensile force, always take plus. Okay. So PAC, what am I assuming? I am assuming compressive sign. Okay. So it should be minus. Remember. So let us find first, and then at the end I will add minus sign. So PAC, what is this angle? You can see, you can calculate the angle first. Here it is 1 meter, here it is 1 meter. So this angle is 45 degree. So this angle is also 45 degree. So I will be getting PAC sine 45 degree is equals to 10 kilonewton. So what is PAC value? PAC value is 10 by sine 45. Sine 45 is 1 by root 2, right? It is 1 by root 2. So I will be getting 10 root 2. 10 root 2 kilonewton is my PAC value. Simple. But what is the sign? What is the sign? You have assumed it as a compressive force. because I know sigma y to be equal, the downward force should be equal to upward force. That's the only reason why I have assumed compressive, just by logic, just by common sense. So what should I write? I write PAC is equals to minus 10 root 2 because it is a compressive force. It is going towards the joint. Never forget this point. So now let us calculate what is PAB. How to get PAB? Very simple here. Do sigma x is equals to 0. That's it. Do sigma x is equals to 0. What will be getting? P. Let us, if this is this direction, right? So this component will also be in this direction. So I am assuming my PAB is in this direction. It is tension force going away from the joint. Okay. What is tension? If I have a joint, if the force is going away from the joint, it is tension, and if the force is coming towards the joint, it is compression. See, this force PAC, it is going towards the joint, therefore it is a compression. I am assuming PAB, it is going away from the joint, so it is a tension. Always remember PAB is equals to sigma x is equals to 0, right? PAB is equals to PAC cos 45. So what is PAB value? It is 10 root 2 cos 45. Cos 45 is 1 by root 2, right? So you will be getting 10 kN. Done. So simple, right? There is nothing much here. So I got my P values 10 and minus 10 root. Okay, now let us get K values. What you have to do? In place of 10, just use 1. Okay, I have already solved. Now you do on your own, get your values. Okay, do on your own and get your values. So if you are doing, see, for 10 I got this 10 root 2. For 1 I will be obviously getting 1 root 2. For 10 I got this force as 10. For 1 I will be getting 1 only, right? So common sense. So you need not solve again, use your logic. So I will be getting 1 root 2 as my K1 or KAC and 1 as my KAB. Just substitute that. Make a table like this. First column is member, second column is P value, third column is K, fourth column is length. Length can be different, right? So make length column also. If areas are changing, if area, cross section area is changing, right, you have to make column for AE also. Okay, you have to make column for AE also. But here nothing is mentioned, so I am assuming the area is constant, no issues. So what is your PKL by AE? First calculate PKL. How to calculate PKL? Just let me erase this. How to calculate PKL? You take this PKL value and take PKL value of AC and add both. You will be getting summation of sigma PKL. Okay. So 10 into 1 into 1, I got 10, minus 10 root 2 into minus root 2 into root 2. Length, he didn't give root 2, but you can calculate, right? See, using Pythagoras theorem, this length was 1 meter, this length was 1 meter. So obviously this length is under root 1 square plus 1 square, which is root 2. I hope you know at least this, right? So just substitute it, 10 plus 20 root 2. Your sigma PKL value is 10 plus 20 root 2, which is nothing but 38.28 units. Okay. So what will be my sigma V, deflection, vertical deflection at joint A? Delta VA means vertical deflection at joint A. Delta HA means horizontal deflection at joint A. Okay. So what is the vertical deflection at joint A? Sigma PKL by AE, which is 38.28 divided by AE, because PKL by AE, right? Very important point, don't forget, if you got the positive value, that means the deflection which you got is in the same direction of the applied unit load. Okay, I'm not talking about the virginal load which was there, virginal W. I'm talking about the unit load which you are applying. If I got positive value, that means your deflection is in the direction of the applied unit load. See here, the applied unit load, my 1 kilonewton, one unit, it was downwards, right? So positive 38.28 by AE, that means the deflection is also in the direction of this unit load. So it got deflected something like this. Okay, I hope you are clear. So let us continue with the next question, which is also very important. Find horizontal displacement for A in the above question. So what do we have to do? We have to apply, instead of in the previous case, what we have done? We have removed this 10 kilonewton load and applied one unit load in the vertically downward direction. Okay, because we want vertical displacement, right? But here I want horizontal displacement, so I am not applying vertical load, but I am going for a horizontal load like this. Okay, very simple रहेगा भाई, कुछ भी नहीं है. See, we have already solved for p values. P values will remain same. Nothing is going to change. For 10 kilonewton, you have to find the p values p1 and p2. Done. Now let us find k1 and k2 values. Very simple. See, there are two forces meeting collinearly, and the third force is meeting these two forces with some angle, and there is no external load. So what should be this force k1? It should be 0. That's it. As these forces are collinear, it should be have equal forces, right? So this is going away, so this should also go away 1 unit. So I am getting tension 1 unit as my force in the member A, B. So simple. Just substitute, you will be getting your answer. 10, P value in the member AB was 10, K value was 1, and length was 1 unit. So PKL is 10, and AC, my P value is minus 10 by root 2, my K value is 0, my length is root 2, my PKL is 0, because anything into 0 is 0. So summation of PKL is 10, right? So delta HA, horizontal displacement at the joint A, is nothing but 10 divided by AE, PKL by AE. And again you got a positive value. If there is a positive value, the applied unit load and the deflection whichever you got is in the same direction. So your truss is moving in the right side direction. Okay, right hand direction, the direction in which you have applied unit load. If in place of 10 you got minus 10 by AE, that means even though you applied load in this direction, there is a deflection like this in opposite direction to the left side. So your beams got deflected something like this. Okay, it got moved to the left side. Okay, so I hope everything is clear. There is nothing much in this chapter. Very easy chapter. Only thing which you have to be careful is related to the sign convention. Okay, so everything is crystal clear. Practice hundreds of questions so that you will never make a mistake in sign conventions. See, while reading you will be feeling that you are perfect in sign conventions, but believe me, many of you will end up making mistakes in sign convention. So please do practice at least 50 questions from Trusses. Okay, now let us see a small note. This note is very simple. There is nothing much in this note. Okay, so in the previous problem we have seen the deflection due to applied load, but in this problem we will see deflection due to change in temperature. Okay, basically if I have a truss something like this, and if there is load applied, obviously it will show some deflection. But instead of load being applied, if there is no load, but if there is a temperature rise, what will happen? These members will try to elongate, right? When these members are trying to elongate, obviously there will be the deflection from the original position. Agree? Or if there is some temperature decrease, again these members try to contract, so again there will be deflection from its original position. Okay, so how to calculate how much deflection is there? Very simple. What is your delta value, deflection value? PKL by AE, right? I hope you remember from SOM, if there is any load applied, for example, if there is any load applied, what is the deflection, or delta L? PL by AE, right? Same thing, Baba. That deflection is PL by AE. So what I can do is, in place of PL by AE, I am writing it as delta, the deflection. Okay, deflection due to loading. So I can write the deflection is summation of K into deflection due to load, right? Agreed? Summation K into delta. Okay, now there is no load. In place of delta due to loads, we have delta due to change in temperature. We have delta due to change in temperature. Okay, what is delta due to change in temperature? L alpha T. And what was the stress induced due to change in temperature? Alpha TE. I hope you remember at least the small formulas from SOM, right? So what is your delta? L alpha T. Even if you don't know, don't worry. After essay, maybe in the next month, I will start SOM. I only will teach, so you will be perfect in it, no issues. But I hope you at least remember these two small formulae. It will be very handy. So change in temperature was the deflection due to change in temperature was L alpha T. So in place of PL by AE in this formula, just substitute L alpha T and you will be getting your answer. That's it. Simple, right? See, if your delta value, whatever is there, if it is a positive, that means the temperature has been raised. If there is a temperature fall, this delta value you have to substitute as negative in the formula. Okay, in this formula, when you are using summation of L alpha T into K, if there is a temperature rise, use this delta positive value. If there is a fall, then use this delta value as negative, because there will be contraction, right? there will be decrease in there will be change in the direction of deflection. Therefore use negative value. That's it. Okay. Now let us end this module quickly by solving this problem. What we have to do, we have to find what is the vertical deflection at joint B, and two members AB and BC are subjected to temperature rise of 50 degrees. This clearly means only two members have been subjected to temperature rise, and remaining members there is no change in temperature. Okay. So alpha value is 10 into 10 to the power of minus 6 per degree centigrade. So what is the formula for finding deflection? K into delta, where delta was PL by AE for load and L alpha T for temperature, right? So summation of K into delta. So what all you have to do, you have to find K due to the unit load, and where you have to apply unit load wherever you want to find deflection. Here we have to find deflection at joint B, so apply unit load in vertical direction at joint B. And L alpha T, he has given everything. Length is given here, right? Length is 3 meters for AB and length is 3 meters for BC. Okay, as the delta is given only for two members, for the rest of the members your delta value is 0 0 0 0, right? For this L alpha T, for these two members delta is L alpha T. So obviously you need not waste your time in calculating K values for all the members. You can just calculate K1 and K2 for these two members and do summation of K delta, K1 delta 1 plus K2 delta 2, and you will be getting your answer. Okay, now let us solve this. Just give me a second, let me erase this. So please pause the video and do this problem on your own and check your result with my answer. Okay, so what you have to do, this length is given as 4 meters and this length has been given as 3 meters, right? So first let us calculate delta L alpha T. So we know all, length 3 meters, alpha was 10 into 10 to the power of minus 6, and temperature rise was 50 degrees. As the temperature rise, the delta should be positive. So what we will be getting, 15 into 10 to the power of minus 4. Okay, that is your delta. Now let us calculate K. So where you have to apply unit load, wherever you want the unit deflection. So I am applying 1 kilonewton load at B. Okay, now see this joint. There are two members meeting and no external load, so 0 0. Again, now see this point, see this joint D. There is external member, but it is 0 force, so you can ignore it. So two members meeting and no external load, again 0 0, right? So obviously it will be carrying some load. This member will be carrying some load because sigma y should be equals to 0, and this member will also be taking some load, right? Now let us calculate what are the forces in the member AB and BE. Okay, how to get this force in the member BE? How to get this force due to unit load in the member BE? Very simple, use sigma y is equals to 0 at the joint B. Okay, so what is this angle? Theta. What will be the theta? If this is 4 meters and this is 3 meters, obviously my hypotenuse will be 5 meters. So if I am taking cos theta, what will be the value of it? Cos theta will be nothing but 3 by 5, right? This length divided by hypotenuse, right? And what will be your sin theta? Sin theta will be 4 by 5, opposite divided by your hypotenuse, right? So just using these two, you can find out what will be the component of BE along the y-axis. That will be BE, KBE sin theta. So KBE sin theta is nothing but KBE sin theta is equals to how much? It should be 1 kilonewton. So KBE is nothing but sin theta was 4 by 5, right? So if you send 4 by 5 to this side, what you will be getting? KBE is equals to 5 by 4 or 1.25 kilonewton. 1.25 kilonewton. That's it. I got KBE value and I have assumed the direction as tension and it is correct. Okay. Now I am assuming the direction as compression because obviously this is going this side, right? The component of BE, the member BE will be going like this. It is going in this direction. So obviously to be in equilibrium, my force in the member in the member AB should be going in this direction. Agreed? So obviously it should be in a compression, but let us see, I am just assuming compression. If the negative sign comes, then again I have to change it to tension, right? So let us see if my assumed direction is correct. Okay, so just do sigma x is equals to 0 at the joint B. What you will be getting? K B E, this is theta, right? So x component will be cos theta is equal plus AB, sorry, is equals to, right, because opposite directions, is equals to KAB. So what is KAB value? it is KBE. KBE yani it is 1.25, right? 1.25 into cos theta. Cos theta is 3 by 5. So 3 by 5. So you will be getting 0.75 and my assumed direction is correct. So 0.75 compression. Okay. Even if you have taken the direction like tension, for example, I have taken compression directly, so I got positive value. But if you have taken tension, what you will be getting? You will be getting the value as minus 0.75. That means it is compression. Okay. You can write it as KAB is equals to 0.75. In the bracket, you can mention compression. Okay. Both ways. The concept should be clear. Please be careful about sign convention. Concept should be very clear. If something is going away from the joint, then it is tension. If something is coming towards the joint, then it is compression. Okay. Always remember that. Okay. Now what you have to do? You got everything. Just you have to do sigma delta VB, which is nothing but KAB plus delta into delta AB plus KBC into delta BC. Okay. K and deflection of the corresponding member. That's it. So KAB I got 0.75 compression. So compression, so therefore I am taking it as minus value into my delta was 1.5, 15 into 10 to the power of minus 4. Okay. Plus KBC. KBC is 0, right? Here it is clearly, we got clearly the value of KBC is 0. So KBC into delta will be obviously 0. So this into, where is my sketch? Into 0. Okay. So what I will be getting? 0.75 into 10 to the 1.5 into 10 to the power of minus 4. I will be getting minus 1.125 into 10 to the power of minus 3 meters. Okay. Therefore my deflection is 1.125 mm as the minus sign is given. So it will be the opposite direction of applied load. Okay. I have applied the load, unit load. I have applied the unit load. You can see in this diagram also. I have applied the unit load in vertically downwards direction. Right? You can see it, right? Just give me a second. Yeah. Here I have applied 1 kilonewton in downward direction. But I got minus value. That means as the temperature is rising, this joint B is going upwards. Okay. So this joint B is actually, the structure is something moving like this, you can say. Okay. So it is going upwards. Okay. I hope it is clear, right? It will be linear member only. It will be going upwards. Okay. So your deflection is 1.125 mm upwards. That's it. So end of this module. In the next module we will solve similar problems, similar 1-2 problems, and then we will end this chapter. Okay. We will also solve a lot of ESC questions if possible in the next module. If not, then in the module number 15. Okay. Have a nice day and practice whatever I taught today at least twice. Okay. Have a nice day. Bye.